Welcome to Expressions and Equations for MAT021. Today we're going to be looking at 6 examples, and in those examples we're going to determine if it's an expression or an equation. For our examples here, that's the first thing, label it. We are going to simplify the expressions, evaluate it if we have been given values for the variables. If it's an equation, we're going to solve it, and we recommend that you check your answers. And any answers we do get, we're going to round to the nearest hundredth if necessary. Okay, so looking at number 1, if we're going to label this as an expression or equation, we have an equal sign here. That equal sign right there tells me straight off I have an equation. So now I'm going to solve my equation. So to solve my equation, I need to remove all values from the variable. So I'm going to subtract 35 because since I'm adding it, to get rid of it or move it to the other side, I would have to subtract it. So z, those will subtract out, will equal, so 42 minus 35 will give me 7. So for number 1, part A, we have an equation, and then when we solved it, z equals 7. Okay. Now I can check that, plug that back in, see if it really does work. So 7 plus 35, and we would see if that equals 42. Well, if I add 7 and 35, I do indeed get 42, so that is a check. So that is my answer. It's not the check that's the answer, it's the z equals 7 that is our answer. Okay, looking at number 2, or example 2 here, there is not an equal sign in this one. So since there is no equal sign, this is going to be an expression. With expressions, we can simplify them. Sometimes they'll come down to a number, sometimes it'll be some variables and some numbers, but there will not be an equal sign in my final answer. So the first thing I'm going to do for this one is distribute my 2 into my first parentheses. So that would be 2x minus 14. Now for that second parentheses, there's a minus sign there. That minus sign also has to be distributed into that parentheses. So a negative times 3x is going to become a negative 3x, and that minus or negative distributed into that 4 is going to make it a minus 4. Now we can combine like terms. 2x and a minus 3x will give me a negative x. And then negative 14 and negative 4 would be negative 18. So my final answer, my simplified answer for this will be negative x minus 18. I cannot combine the x and the 18. I can't say that x equals 18. I do not know what x is. Okay, so for an expression, it's okay to have a set of terms as your answer. Again, with an expression, you will not have an equal sign in your answer. All right, let's look at example 3. For example 3, we have an equal sign in here, which tells me right away we have an equation. So for this equation, I'm going to try to, or I want to not have a fraction. So the easiest way to not have fractions is to multiply through by a least common denominator. In this case, my whole denominator. So I'm going to multiply both sides by y plus 9. So when I do that on the left-hand side, those would divide out and go away, leaving us with just 15 equals, and then on the right-hand side, we will have 3 times the quantity y plus 9. We need to distribute our 3 into the parentheses. 15 equals 3y, and 3 times 9 will be 27, so plus 27. Remember, with an equation, the goal is to get the variable completely by itself. So then I'm going to subtract 27 on both sides. 15 minus 27 will give us a negative 12 equals 3y, and 27 minus 27, those will subtract out and go away. All right, my next step will be to divide by 3 on both sides. So divide both sides by 3 to get that y by itself. So negative 12 divided by 3 will be a negative 4. So y will equal negative 4. Again, we can check this. So we would plug that negative 4 in where we have the y in our equation. So 15 over negative 4 plus 9, and we would see if that equals 3. So that would be 15 over negative 4 plus 9, which would be 5. And 15 divided by 5 is indeed 3. So that checks. So our answer is that y equals negative 4. We will look at examples 4, 5, and 6 in our next video.